Dear friends, welcome to Bond with Chemistry YouTube channel. In this video, I will explain the previous year questions which are appeared in HCU PG Entrance Examination from Inorganic Chemistry from the year 2017 to 2018. These are year-wise questions from Inorganic Chemistry. Among the following, the molecule having the longest bond length is. Here the molecules are given NO, NO plus, NO2 plus and NO minus. Here the number of electrons, let's take NO. This one has nitrogen 7 and oxygen 8, 15 electrons. This one has 14 electrons. This one has 13 electrons. This one has 16 electrons. We know the bond order for the molecule which is having 14 electrons, it will be 3, and 16 electrons, the bond order is 2. So for 15, it is in between 3 and 2, 2.5. And 13, it is also 2.5. You know that the bond length is indirectly proportional to bond order. As the bond order increases, it means the number of bonds between two atoms increases, bond length decreases. NO minus, it has less bond order, means it has more longest bond length. So what is the correct option? NO minus is the correct option. Excess acidity caused by acid rain to the soil can be neutralized by the acid rain. The acid can be neutralized by base. So addition of more fertilizer, removal of acidified soil. Okay, it's very difficult. Addition of cesium carbonate. This one also base, but the cesium, which is not useful for the growing of plants. But if you take addition of lime, calcium carbonate, it's a base which can neutralize acid, and also the ions, the calcium which is present in the calcium carbonate will be used for the growth of plants. So generally we use lime for the neutralization of acid rain soil. The molecule processing non-zero dipole moment is, okay, here carbon tetrachloride, this one is tetrahedral. The dipole moment is 0. It's a symmetric molecule. And the xenon tetrafluoride, it's a square planar, and the two lone pairs on axial position. And here also the net dipole moment is 0. And SF4, this one has a seesaw shape. So this one has a dipole moment. So this is the shape of SF4, and this one has lone pair of electrons. This is the seesaw shape, and this one has net dipole moment. It's not is equal to 0. PCl5, this one also symmetric, and this is the structure. The net dipole moment, there is a cancellation of these two, and it's a planar, cyclic trigonal planar. Here also mu is equal to 0. So which one has non-zero dipole moment? SF4 has non-zero dipole moment. The hybridization of sulfur in SF4 molecule is, how can you calculate, or how can you identify what is the hybridization? The number of hybridized orbitals, HOs, will be equal to the number of electrons on central atom. Here the number of electrons on central atom is 6 electrons, plus monovalent around sulfur 4, charge on the molecule 0 minus 0 by 2. So it will be 10 by 2 is equal to 5 hybridized orbitals it has. So the hybridization will be sp3d. So this is the correct option. Zinc uranyl acetate and Nessler's reagent are used in the confirmatory test of the following cations. Okay, Nessler's reagent, we know this one used for the confirmation test of ammonium, NH4 plus ammonium cation, and the zinc uranyl acetate, this is the zinc uranyl acetate, UO2, and CH3COO, so 4 times Okay, when you react with sodium, there is a formation of yellow colored complex, there is a formation of yellow colored solid. Here you will get NaZnUO2 thrice CH3 COO 6 times. This is the yellow colored complex you will get. So sodium is used for zinc uranyl acetate is used for the conformation test of Na plus, and Nestle's reagent this is used for the conformation of NH4 plus. The non-aqueous solvent BrF3, the nature of SbF5 is there is a solvent method. In solvent method, the BrF3, this one is there is auto dissociation of a solvent into cation and anion. You will get the BrF2 plus and BrF4 minus. Suppose if we add any substance, if the substance increases cations, the number of cations, then that one will be acidic. It increases cations of auto-dissociated species. And basic compound, this one increases anions. Suppose if you add SbF5, this one attracts F minus, so there is a formation of BrF2 plus and BrF3. F minus will be react with SbF6 minus. So finally here there is an increase in amount of BrF2 plus. There is an increase in cations. This is the auto dissociation. After addition of SbF5, there is an increase in BrF2 plus ions. So there is an increase in cations. So the compound SbF5 is acidic. ClF3 molecule is. Okay, let's find out what is the hybridization of chlorine in ClF3. The number of hybridized orbitals will be equal to the valency of central atom, that is 7, plus number of monovalent around the central atom 3 minus 0 by 2. So it will be 10 by 2 is equal to 5. There is a involving of 5 hybridized orbitals, so the hybridization will be sp3d. The VSEPR geometry will be trigonal bipyramidal. This is the geometry, and here you have Cl, and this is the geometry of sp3d hybridized orbitals. And you have here you have fluorine, and here also you have fluorine. Here fluorine. The two lone pair of electrons will occupy the two equatorial positions. So you have T-shaped. So the correct option is A. The paramagnetic species among the following is odd number of electrons. Odd electrons. If the molecule has odd number of electrons, it has unpaired electron. Unpaired electrons. So this one is paramagnetic. Let's find out the molecule which is having odd number of electrons. Here two nitrogens, 7 plus 7, 14 plus 8, it's even, and NO2, 7 plus 8, it's odd, so it has the unpaired electron. NO3 minus 7 plus 3 into 8, minus 1 means you have to add extra electron. It is also even, so this one is diamagnetic, this one is paramagnetic. N2O4, 7 plus 7, 14, and 8 into 4. It is also even, so this one is diamagnetic. What is the correct option? NO2 is the paramagnetic. Names of O2 minus, O2 2 minus, O2 plus are respectively. Here we have different types of oxides. Normal oxide, this one has O2 minus. Peroxide, O2 2 minus, and superoxide, O2 minus. This is the normal and peroxide, and this is the superoxide. And O2 plus, it's a dioxygenyl, it's a cation. Dioxygen cation. So O2 minus is a superoxide, and O2 2 minus is a peroxide, and this one is a dioxygenyl cation. The number of OH and the P double bond O groups present in triphosphoric acid are respectively. Triphosphoric acid is a condensation of three orthophosphoric acids. If you take, when you do condensation, you will get the triphosphoric acid. This is the structure of triphosphoric acid. P double bond O, the remaining will be OH. OH, and here you have only one OH. This is OH, and this is also OH. In this we have OH 1, 2, 3, 4, 5 OH, 5 OH groups, and the 3 PO groups. Among BrO4 minus, SiF4, TeF4, ICl4 minus, the species isostructural group xenon tetrafluoride. Xenon tetrafluoride, this one has sp3d2 hybridization, and it has a structure of square planar. This is the structure. And here you have lone pair of electrons, the fluorine, and also fluorine. If you take BrO4 minus, this one has a tetrahedral structure. Tetrahedral. This is the structure. sp3 hybridization. So you have this is a tetrahedral structure of BrO4 minus. And the SiF4, this one has this one also has a tetrahedral structure. sp3 hybridization, tetrahedral. And the TeF4, and thus oxygen, sulfur, selenium, and tellurium. This belongs to it has a SF4 like structure. So this structure is CISA. And ICl4 minus. What is the hybridization? The central atom, it has a 7 valency, 4 monovalent, minus of minus plus 1 divided by 2. It will be 6. It will be 6 means the hybridization of ICl4 minus is sp3 G2. Similarly, it is similar to the XeF4, and you have this structure like this. Here ICl, Cl, and you have two lone pair of electrons. So the correct option is IClO4 minus. Among the following pair of diatomic molecules, choose the one where the bonding sigma 2p orbital is lower in energy than pi 2p orbitals. In molecular orbitals theory, if the molecule has 16 or more than 16 electrons, 16 or more than 16 electrons, the electronic configuration is different. Less than 16 electrons, the electronic configuration is different. Less than 16 electrons, the sigma 2p, this is the sigma 2p, this one has higher energy than pi 2p. This is for 16 electrons, less than 16 electrons. If the molecule has 16 or more than 16 electrons, this one, in this case, the sigma 2p has less energy, and pi 2p, these two have more energy. Here, if you take O2, this one has 16 electrons, and F2, 18 electrons. In both the cases, the energy of pi 2p or the energy of sigma 2p orbital is lower in energy than pi 2p. Suppose if you take this one 16 electrons, but this one 10 electrons. In this case, pi 2p has less energy, and C2, this one is for 12 electrons, 18 electrons, and here 16. Here 18 electrons and 10 electrons. When the number of electrons 16 or more than 16, then the sigma 2p has lower in energy. The most abundant transition metal in Earth's crust is, so this is the abundance of elements: oxygen, next one is silicon, aluminum, next one is iron. This is the order. Okay, oxygen is the most abundant on Earth's crust. Next one is silicon. Metal is aluminum. Most abundant metal is aluminum. The most abundant transition metal is iron. So here transition metal is asked. So the answer is iron. The fragment which is isolable to FeC4 minus. This isolable analogy, this one connects inorganic molecules with organic molecules. It connects inorganic with organic in structural way. Suppose if we take CH4, this one is isolable with CrCO6. If you remove one proton, one H, you will get CH3 minus CH3 free radical. Then this one is isolated with the MnCO5. You have to decrease one CO, and there is an increase in atomic number. And the CH2, this one is FeCO4. And the next one, CH, if you take, this one is isolable with cobalt CO thrice. So isolable of FeCO4 is CH2. The spin-only magnetic moment in Bohr magneton of high spin Mn3 plus ion is Mn3 plus ion high spin. So here, if you take high spin Mn3 plus 1, 2, 3, 4, 5, the electronic configuration of Mn3 plus will be D4S0. Mn is D5S2. You have to remove 3 electrons, it will be D4S0. High spin means 1, 2, 3, 4, no need to pair, and it has 4 unpaired electrons. So the spin-only magnetic moment mu is equal to root over n into n plus 2 Bohr magneton. So here n is 4, 4 into 4 plus 2 means 4 into 6. It will be root 24. It is less than root 25. So it is slightly less than 5. So what is the answer? It will be 4.90. Match the following. Here the HGS, it is called as cinnabar. This is a cinnabar. MnO2, pyrrole U site. This one is pyrrole U site. And CuFeS2. This one is chalcopyrite. Chalcopyrite. FeTiO3 is limonite. And SnO2, gastrite. Mg2SiO4 belongs to the class of. Here we have what type of units we have. This one Mg2SiO4. When you remove Mg2 plus ions, okay, each Mg carries plus 2. Mg2 plus means we have to remove 4. It will be 4 minus. The silicate contains SiO4 4 minus, so it's a orthosilicate. The correct order of basicity of the group 15 trihydrates is in 15th group trihydrates, the basicity decreases from NH3 to what is the reason? Here there is an increase in size of atom. When there is an increase in size of atom, there is a more distribution. If you take here you have a 2p orbital and a 3p orbital and 4p orbital. The size of 4p orbital is greater. So the lone pair of electrons which are present on the arsenic will be distributed over more volume. So the availability of lone pair of electrons is less. So NH3 is more basic, next PH3, next ASH3. The first noble gas compound reported is Berthollet. We synthesized first noble gas compound, that is xenon, PgF6. This is the first synthesized. This one is similar to O2 plus PgF6 minus. The shape of NO3 minus is. Here we have to find out hybridization. Here the valency of nitrogen is 5. The monovalent is 0. Since oxygen is a divalent, minus of minus 1 charge, minus charge by 2. So how many hybridized orbitals are there? 3 hybridized orbitals. 3 means sp2 hybridization. sp2 you can write like this. And this is the sp2 hybridized. So the shape is trigonal planar. The species having shortest bond length among the following is. Again, you have to arrange. Yeah, the species having shortest bond length among the following is. Here NO is given, NO plus is given, NO2 plus is given, and NO minus is given. For NO plus you have 14 electrons, NO minus you have 16 electrons, 15, and this one 12. For 14 electrons bond order What is the bond? The 3. It's a 3. It's a 2. 16 electrons 2. It's in between 2.5. 3 and 2, 2.5. Here also 2.5. But if you take bond order, equal bond order, if you take bond order, which one has less bond order, that one has more bond length. Which one has more bond order, that one has less bond length. Suppose if you take NO plus, this one has more bond order, it has 3 bond order. So the bond length will be least for NO plus. Choose the planar species for the following. This one is planar, square planar. This one is tetrahedral, it's not planar. PDCl4 2 minus, it is also square planar. SP, this one is square planar, this one is tetrahedral, this one also tetrahedral. SP3 hybridized MnO4 minus. So here also tetrahedral shape you will get. Which are planar? HCF4 and PDCl4 2 minus 1 and 3. The VSEPR geometry will be identical with the molecular geometry for. Here the VSEPR geometry, this one tells the arrangement of bond pairs and also lone pairs. But molecular geometry, we have to consider only bond pairs. Suppose if you take AlCl3, this one has a trigonal planar. The VSEPR geometry and the molecular geometry both are same. But if you take SF4, this one has seesaw. This is the structure you will get. This is the S, F, and F. This one F. This one has lone pair of electrons, seesaw. And the molecular geometry is seesaw, but the VSEPR geometry is trigonal bipyramidal. And ICL3 also. Here, if you take ICL3, this is the geometry. Here, Cl, here you have a lone pair of electrons. The VSEPR geometry is trigonal bipyramidal, but if you take molecular geometry, it's a trigonal planar. Xenon tetrafluoride also. This one has sp3d D2 hybridization. Here VSEPR is octahedral, but if you take molecular geometry, this one is square planar. So AlCl3 has both the geometries identical. Which of the following metal ions can give both high and low spin octahedral complex? We have D1, D2, D3, D4, D5, D6, and D7, D8, D9, and G10. Okay, these electronic configurations, if you take, they cannot exhibit both high and low spin octahedral complex. But if you take D4 to D7, these exhibit both high spin and low spin. If you take Cr3 plus chromium 3 plus, this one is D3 electronic configuration. Fe2 plus, it has D6 electronic configuration. Cu2 plus, this one has D9 electronic configuration. Titanium 3 plus, this one has D1 electronic configuration. So here D3 cannot exhibit D9 also, D1 also, D6 can exhibit both high spin and low spin. Spin-only magnetic moment of a high spin complex Fe3 plus, high spin we have to take. The electronic configuration of Fe3 plus is G5. So high spin, how many unpaired electrons will be there? 1, 2, 3, 4, 5. It's a high spin complex. You have 5 unpaired electrons. N is equal to 5. Then what is the spin-only moment, magnetic moment? Mu is equal to root over n into n plus 2 Bohr magnetron. It will be 5 into 7. It will be root 35, slightly less than root 36, slightly less than 6. So the answer will be 5.92. Which of the following is a correct description of gas phase structure of xenon F6? Okay, xenon F6, let's take what is the hybridization. The valency electrons 8 and monovalent 6. There is no charge, 0 by 2. So it will be 14 by 2. So it has 7. The hybridization will be sp3d3. This is the hybridization. sp3d3 is the hybridization. Here you have one extra lone pair of electrons. So it has a distorted octahedral. There is no possibility of perfect octahedral since it has a lone pair of electrons. And trigonal prismatic is not correct. Polymeric with xenon octet, which is also incorrect. What is the correct option? It has a distorted octahedral. When dilute HCl is added to a white salt, effervescence is observed along with a colorless and odorless gas. So here there is a release of CO2. Then a white precipitate is also formed which dissolves on heating. The salt is. Suppose if you take lead carbonate, when you add HCl, there is a release of effervescence and there is a formation of lead chloride, white precipitate, and there is a release of CO2. And this white precipitate, EPT, when you heat it, there is a formation of clear solution. If you take another sodium chloride or zinc chloride, mercurous chloride, all these chlorides does not follow this trend. NaCl, it's not white precipitate. Zinc chloride, it's a white precipitate, but there is no dissolving after heating. Okay. So the correct option will be lead carbonate. The borane can be classified as B8H8H8 minus. Here we have closo, nido, arachno, and hypo. Then what are the formula? And this one has BnHn2 minus or BnHnHn plus 2. And this one has BnHn plus 4 and BnHn plus 6. And this one has BnHn plus 8. B8, let's take B8 and Hn plus 8, let's take 8 plus 8, 16. When you remove 8 hydrogens, you will get B8H8 8 minus. So the correct option is hypoborane. In coming video, I will explain the part 3 of inorganic chemistry. Thank you.